Okay, adding and subtracting fractions. Okay, so in this first one here, we've got to take away, all right? And the only way we can add and subtract fractions is if we can get a common denominator, okay? And what I mean by that is the number on the bottom has to be the same, okay? Has to be common, right? And remember, the bottom number we refer to as the denominator, all right? But they're not the same, aren't they, in this case, all right? So usually it involves changing at least one of those fractions. Sometimes we have to change both of the fractions. In this case, though, we only have to change the second fraction here, okay? Because we can actually get a common denominator here of 10. And the way I do that is to change 1/5, okay? So I find an equivalent fraction for 1/5, okay? And I make that so that this is out of 10, all right? And it's possible to do that, okay, by upscaling it, right? And you just got to think to yourself, well, what do you do to 5 to get to 10? And of course, we need to double it, yeah? Okay, so we double 5, we get 10. But we do the same then to the top. Remember, with the equivalent fractions, whatever you do to the bottom, you must do to the top. So we times the top by 2, and we'll get 2, so 2/10. And then what we have then is, this is already out of 10, isn't it? So we'll keep that as 9/10. And we take away then 2/10, okay? And we get our answer then of 7/10, because 9 take away 2 is 7, and we keep the bottom number as 10. All right. When we go to question 2, we're adding. All right. And again, I only need to change one of these fractions. Okay. So that actually we'll end up having then a common denominator of 8. All right. And I can do that, can't I? And that's the whole point about this. I can change these so that they both out of 8. Okay, quarter there, let's change this so it's out of 8. Okay, of course, 4 fits into 8 nicely, doesn't it? How many times? Well, I've got to times 4 by 2, and that will give me 8. So times the top by 2 as well, so I get 2/8. Okay, to finish off then, of course, 1/4 will be 2/8, and then you add the 3/8, so you get 5/8 in total, all right? So the number on the top is 5, and the number on the bottom is 8. Now, in this question 3, we've got a situation where we have to change both fractions, okay? Because we can't get them both so that they're out of 12, right? That's impossible to do that, isn't it? You know, that one's out of 12, but we can't sort of scale that up to get 12, you know? If I was to ask myself, what do we times by 8 to get 12? Well, you can't you? Okay? You can't. If we double it, we get 16, so we're going to miss 12 out. So we need to get a common denominator for these two, all right? So what we do is we need to think of a number that 12 will go into and 8 also goes into. So we need sort of like a common multiple. And one way you can do it is to sort of write out the multiples, okay, here. So what I mean by multiples, like the tables, yeah, of 12. So 1 times 12 is 12, 2 times 12 is 24, okay, 3 times 12 is 36, 4 times 12 is 48, and so on, right? So that's the 12 times table. Let's do the 8 times table, right? 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24. And actually I can stop now, because if you notice, there's 24 in both lists. So 24 is a common multiple. So what I'm going to do now, I'm going to change both fractions so that they are out of 24, right? Now we just got to ask, okay, what are we doing here to 12 to get 24? Well, we're doubling, aren't we? We're doubling it. So that means you've got to double the top, all right, as well. So double the top, you get 22, all right? And the other one we can change, can't we? We can change that one to it's out of 24. What are we doing here to the 8? Well, we're tripling it, aren't we? Yeah, because 8 goes into 24 3 times. Okay, so 8 times 3 is 24. So that means, of course, then we've got to times the top by 3, and we get 15. All right. Now we are taking away. Okay, we are taking away. So instead of taking away these two fractions now, though, we'll take away this fraction. We'll take away the other fraction here, the equivalent fraction that we've got for 5/8. So we can take away these instead. And now, because the bottom numbers are the same, we just take away the top numbers, and we get 7 there. 7 out of 24. Okay. Right, so with question 4 then, just to finish off, says here, Simone is asked to add 3 1/10 and 4 8/9. She estimates the answer to the nearest whole number. Okay, so explain how Simone may have found her estimate and write down what this estimate would be. Okay, so she's going to estimate her answer, okay, and she's going to, notice that she's going to estimate the nearest whole number. So what would her estimate be? We need to think. Okay, now what we need to look at here, what we need to realise is this is a mixed number. We've got 3 wholes and 1/10, and then we've got 4 wholes and 8/9. Okay, now if we consider the whole numbers first, right, we've got 3 and 4, haven't we? So adding them together, that would give me 7 wholes, okay, but we'd need then to think about adding the fractions as well. So that's how I would add mixed numbers, okay? To add mixed numbers, I'd add the whole numbers first. So 3 wholes and 4 wholes is 7 wholes. Then we'll add the fractions, 1/10 and 8/9. Okay, so we need to add these. Now when we add these, right, when we add these, of course the bottom numbers are different again, so we need to get a common multiple. Okay, a number that 10 goes into and a number that 9 goes into. Alright, so you can go through your 10 times table, you go through your 9 times table, and it actually takes you a while to get a common multiple. Okay, the only one I can think of is 90 here, yeah, because they both go into 90. So we're towards the end of the times table. So we change this one here, so it's at a 90. So we need to times this by 9, yeah? Okay, right, so 10 will change to 90, I times it by 9, which means we times the top one by 9. And then 8/9, change that, so it's at a 90. Okay, now of course to get 9 to 90 you've got to times that by 10. And then of course times 8 by 10, and you get 80. Alright, so instead of having 1/10 and 8/9, we'll have 9/90 plus 80/90, which is 89 over 90. Okay, so my final answer will be how many whole parts I've got, which is 7, and the fraction here, 89 over 90. Now she estimates this, yeah, to the nearest whole number then. Okay, so she rounds it. Now if you think about it, we've got 7 wholes, but this is practically a whole as well, isn't it? So she would estimate it really to 8, because that is almost there, isn't it? It's almost a whole. And there's our explanation and our question answered.